Right. So there is actually another theorem, and this is why I said, like, you're going to have a lot of questions that are going to look very similar to each other. They're just going to have different properties. So what I mean by that is, if you look at this one, like this picture right here looks almost exactly like this one. But we have something additional to some of them that we can use, particularly this one right here, okay? So number one, it says, if MR is, and then we have this symbol. This symbol right here means that they are parallel. So it's saying MR is parallel to ST. So I'm going to go ahead and add the symbols for that. Remember, this is what they look like. In the figure below, explain why, and then it says triangle MAR is similar to triangle SAT. So let's kind of just go over this. So first of all, first thing that I can do is remember, I can always say like, oh, well, if I would separate these, because this is what we usually do, right? We separate them. This little one would be MAR. This big one would be A, S, and T right here. And then one of the first things that I always tell you to do is, like, when you're separating them, right, those two angles that are on top of each other are congruent. So we're going to add arc marks right there. And ooh, that's not a good color. Let me pick another thing. This one and this one are congruent. Okay? All right. So just by that, I can see that I have an A right there. Now, think about this right here. There's a reason that they told you that they are parallel. So let's just kind of talk about that. If I have two parallel lines, and we kind of reviewed this last class, we have two parallel lines, then I can find a transversal. So if I look right here, I actually do have a transversal right there. Now remember, this gives us 8 angles. We have 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now it doesn't mean you're going to use all of them, because if you look, this angle right here has nothing to do. This angle right here, and this angle right here has nothing really to do with the triangle. So I'm just going to go ahead and delete it. Okay. Same thing. This one, nothing to do with the triangle. Let's delete it. This one, nothing to do with the triangle. Let's delete it. Same thing. Let's delete it. Let's delete it and delete it. So we have these two right here. Okay. Now, these two angles, think back on the type of angles that we were looking at when we were looking at parallel lines and transversals. We had alternate interior, alternate exterior, same side interior, and corresponding. So if I look at these two, I see that I have them both on the same side, and one is outside and one is inside. So for this one, these two angles are corresponding angles. And we talked about how corresponding angles, when there's two parallel lines crossed by a transversal, corresponding angles are congruent. So these two angles right here are actually congruent. So we're going to go ahead and mark that up. We're going to mark that up with arc marks like this. Okay. Now, if I transition that to my picture, it would look like that. And that's where you get your second A. So let's just go ahead and write that down really quick. So we know that this angle, and I know I did all of this, right here on my picture, but just remember that angle, and let's give it a name. This angle right here, it's right there on that M. I'm going to say AMR. Okay, is congruent to angle, and this angle right here is right there on the S, so AST or MST, whichever one you want to use. I'll use MST. They're congruent, okay, because they are corresponding angles. Okay, so explain why triangle MAR is similar to SAT by AA, similarity, okay? Right. So now that we know that they're similar, we can go ahead and build a proportion with them if I was trying to find a missing side. So that's what they're looking at, number 2 right there. So they said AM, which is this side right here, over AS, which is this side right here. So they just matched up corresponding sides, so it looks good. And then they said AR right here. And then they're going to fill out this bottom spot. And that's what they're asking you. What piece corresponds to AR in this picture? What side corresponds with AR in this picture right here? Okay. AR corresponds with AT. So right here on that question mark, let's go ahead and put AT. Okay, that's the correct way of writing this proportion. So if I was doing this type of question, let's go ahead and do that really quick. Whoop. This one right here, number 3, it says AM is 12, MS is 9, and AR is 15. So let's transfer that to our actual pictures really quick. So it says AM is 12. So this side right here is 12. And we can redraw this just so it's a little bit less messy if you want. Ooh. So let's do our big one and our small one. This one's MAR. This one is SAT. And it says MA or AM is 12. So let's pop that 12 right there. It says MS is 9. So I don't have MS in my pictures, but we will add it to this one in a second. Then it says AR is 15. So we're going to put 15 here. And then it says determine the length of RT. Okay. So looking at this one really quick. If I was doing this question, I need everything for that big triangle. So let's go back to our original real quick. Okay. One of the things that we talked about, remember, you can always get these sides right here by adding and subtracting. So sometimes when you separate it, we might have to go back to the original to see if we need to add or subtract anything. So this right here was 15. And then the other thing that they said is MS is 9. So this was 9 right here. So if I wanted to get this whole side right here, I would add 15 plus 9. And that would give me 24. Okay. Now, if I was looking for AT for this question right here, I have AR, and I know AR is in, oh, sorry, I did it incorrectly. This one should have been 12. Okay, and this one should have been 9. So it should have been 12 plus 9, not 9 plus 15, sorry. So 12 plus 9, that's 21. There we go. All right. And then AT, right? I don't know what that is, but I do know that AR was 15, right? But I don't know what AT is. Because these two triangles are similar, I can do some work right here to find what AT is. And I'm just going to label that as my X, okay? Because I don't know what that side is. Yes, I know that's not what your question is asking you for, okay? But the reason I am going to put X right there is really I don't have a way to find AT just yet because I need what RT is to find AT, okay? So let's go ahead and build our proportion. We're going to start here, and we have X. And X goes with 15. So I'm going to put 15 right there, right? On the top of that X, we're going to place the thing that goes with X. So on the same shape is that 21. So we're going to put that 21 right there at the top with X. And 21 corresponds with, this 21 corresponds with that 12. So I'm going to put that 12 right below it. Okay? Go ahead and solve for X. All right, to solve for X, I'm just going to go ahead and get rid of that divided by 15 by multiplying by 15. Both sides. When I do that, X equals 2, and then 21 over 12. And then times 15. And that would give me 26.25. Okay. Now, that right there is X. Sorry, the other two sides. Okay. So this converse right here, and like I said, you're not going to use it too much, is if I ask you, hey, how do you know, are these proportion, or are these parallel, yes or no? Essentially, you would just have to look at the numbers and see, well, if it works with the proportion, if they are proportional, then that means that it is parallel. We're not going to see it too much, but I do just want to mention it.